Good afternoon, everybody, and welcome to Eastern Washington, Lake Cascades, more specifically. And up on this ridge overlooking the lake, the Teanaway Formation and the Silver Pass Volcanics. What can we learn about both of those units? Are they volcanic? And if they are volcanic, are they part of the Cascades? Proper. Thanks for joining us. Let's get started. Okay, we've got some good light. I don't know how long it's going to last, so let me just riff and take in these colors here. Let's start with the older unit. Those craggy outcrops are part of something called the Silver Pass Volcanics. We're going to read together a bit in just a little while. Not horizontal layers, but they're dipping quite steeply to the east. You're essentially looking north. And here's Lake Cascades, which is a reservoir that's been dropped way down. I mean, it's almost November 1st. So it's easy to walk around on this lake floor since the reservoir is quite low. And then staying wide like this, up there high with the changing light is the Teanaway Basalt. Layer after layer after layer of the Teanaway Basalt. The cap rock. The flood basalts locally. Not the German chocolate cake, but a far older version of the German chocolate cake. Let's put the iPhone to work. I'll keep pushing in. And we can make some observations, just you and I, from this vantage point. Very good light. These are slightly dipping to the east, but not nearly as steeply dipping as the Silver Pass volcanic layers. And these layers are 49 million years old. So let's cut right to it. Yes, I'm in the Cascades. Yes, these are basaltic lavas, eruption after eruption of basaltic lava, not far from Ellensburg. But these are not the Columbia River basalt lavas, which are 16 million years old. These are the Teanaway basalt lava flows. Yes, they came out of fissures, but the fissures are right here. The Teanaway dike swarm, right here in central Washington, producing this thick stack of Teanaway basalt. For more particulars about bedrock, about detailed ages, about the dikes themselves that produced this Teanaway formation, we're going to go to my portable classroom right over here, which is otherwise known as a tree stump. And sure enough, the Silver Pass Volcanics are now in the shade. But do the Silver Pass Volcanics look different? I think they do. They're a lighter color. They're more steeply inclined, and perhaps they are lithologically more diverse, although we need to read together. Fresh dusting of snow. As we look to the north and spin you around, just to give you your bearings, the low rumble of Interstate 90 is down there beyond the dam, the Cascades Dam. So you're looking west right now, and it's another half an hour up to Snoqualmie Pass. The snow's about to start, down here low even. So I thought I would just run out here after classes today on a Tuesday afternoon. I don't intend this to be a long video. But let's go ahead and read a little bit. Get my toque. Here's my little portable outdoor laboratory. Video laboratory, a little bit of power. I'm starting to get comfortable with these Rode microphones. And let's learn a few basic things here with this nice light. The Straight Creek Fault is a major structure that started 49.3 million years ago and ended, I guess, 35 million years ago. And in green is the Teanaway River block, which is primarily Teanaway Formation and a few other things thrown in. And that's what we're looking at today. More detailed map. Mike's colorblind, so his colors are extra bright. Here's Interstate 90. I came from Ellensburg down over here. And we are essentially at the Gold Star, 1.2. And this is the blue water of Lake Cochise. And we can see that the Straight Creek Fault in Washington then transitions to the Fraser River Fault on the BC side. And it's the Teanaway Formation in very bright red, tomato red, that Mike has outlined for us. Here's an old master's thesis by David Lofgren, who got a master's in 1974 from Portland State University, supervised by Paul Hammond. This thesis area here at Lake Cochise has a Cochise Fault, a major structural feature going north-south right through Cochise Lake. So they didn't even call it the Straight Creek Fault in the early 1970s. One side of the lake, there's metamorphic igneous and sedimentary rocks. On the other side of the lake, similar rocks, but quite a bit younger. There's 100 miles of offset, right lateral offset, on the Straight Creek Fault. Here's what David is telling us about the stratigraphy on this side of the lake. So he basically has the lake coming right through this strat column, and we're looking just on the right side of the lake right now. Eastern Schist, North Peak Metavolcanics. Those are parts of the fruitcake, exotic terrains. I don't think we're going to deal with them much this summer. But unconformably on top of the North Peak Metavolcanics is the Swauk sandstones and shales. Sitting on top of it, the Silver Pass Volcanics, ding, 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 and the Teanaway Formation, ding, ding, ding. We're not focusing on the Roslyn today. We're not focusing on the German chocolate cake, otherwise known as the Columbia River basalts, known locally here, the Yakima basalts. And then very interesting to me, the Hausen andesite, which is just a little blip of andesite up on this ridgetop. Oh, the light's good. Come on now. The light is still excellent on the Teanaway basalt. We're going to talk a fair bit about the Teanaway basalts, or the Teanaway Formation, this upcoming winter. And this is the visual I'd like you to have. Yeah, this is the same Teanaway that's exposed at Liberty, Washington by Rob Reppin's gold mine. And yes, the Teanaway feeder dikes are all through the Blewett Pass area, but those feeder dikes, which are down here in the trees here locally, I mean, there's a bunch of cracks that formed 49.3 million years ago, and those cracks, those feeder dikes, fed the Teanaway thick basalts that capped a swamp back during that time. I mean, we're back at the Eocene 56 hot, you know, it's warm globally. There's all sorts of swamp material. In other words, the Swauk Formation is down here in the trees with all those plant fossils, those palm fronds. But this is one of the few places that we can get a side view, a cross-sectional view of these capping basalts of the Teanaway. And before we quit this video, I want to tell you an exciting new way to understand why these basalts are here. It's the work of Jeff Tepper that's been done in the last few years. Still got my eye on the Silver Pass volcanics, but they're not being helpful. My point is, up there high is this house and andesite, which may very well be an adachite, similar in very young age to the Birch Mountain adachite that Jeff Tepper and his undergrads at the University of Puget Sound studied over by Wenatchee. So I just emailed Tepper last night. I'm like, do you know about this house and andesite? He's like, no, but it would be very cool if we could look at, if anybody's done any chemistry on the house and andesite to see if it's correlative with that Birch Mountain adachite the other side. Silver Pass volcanics. They were named by Foster for the sequence of andesitic volcanic and pyroclastic rocks exposed near Silver Pass at the head of Silver Creek. Now I think Silver Creek is like right up through here, maybe just on the backside of this ridge, I'm not quite sure. And Silver Pass is up there someplace. So this, you're looking at the ridge between Lake Cochise on one side and Lake Cle Elum on the backside of this. And if you're a regular viewer, you remember a few years ago we were looking at the blue schists and the green schists up at French Cabin Mountain. That's right over the hill here. That's up here high, in other words. So there's a lot going on in this ridge between Lake Cle Elum and Lake Cochise, all within 45-minute drive of Ellensburg, I might add. The rocks form steep, rugged cliffs at the north end of Cochise Ridge, as well as the sharp west peak of French Cabin Mountain. Lithology. The Silver Pass volcanics consists of light-colored andesitic lava flows, tuff breccia, and volcanic breccia. The rocks are light gray or brown in color and been deeply weathered. There's more than 3,000 feet of Silver Pass volcanics. Interlayered volcanic and pyroclastic rocks. Some of it's porphyritic, altered, lapilli tuff breccia. You know, more than half of it is lava flows, and less than half of it is pyroclastic deposits. Here's a field shot, old school camera, I'm sure. Steep southwesterly dipping strata, north end of the ridge. The cool thing is that the volcanic vent is right up there. It's right up on that ridge. So this is not like Ohanapakash where we have incredible thickness and green and the source is, you know, 2 counties away. The source is right here for the Silver Pass volcanics. Strat columns from David, aphanitic hornblende andesite, augite hypersthene andesite, vitric lithite lapilli tuff, no big deal. Crystal tuff. Once we get to the breccia, it's poorly sorted angular lithic fragments, ranging in size from a few inches to several feet. The fragments consist predominantly of light green or pink porphyritic volcanic rock and light gray, medium to coarse grained sandstone. Fragments of dense greenish black aphanitic basalt. You can talk yourself into some of those dominant ridges being the lavas and maybe some of the less resistant ledges, some of the pyroclastic stuff, the breccia. But that's me just making it up. Yeah, so these Silver Pass volcanics are on top of the Swak sandstones, but they're underneath the Teanaway basalts. You're like, give me the ages. That's coming with the other work by Mike Eddy. Foster described these dikes, so now we're suddenly talking about the dikes of the Teanaway basalt. Named them the Teanaway dike swarm. And yeah, the dikes that are here represent the western edge of the Teanaway dike swarm. Okay, to the Teanaway basalt, George Otis Smith named it. There's interbedded pyroclastic exposed in the middle of the fork of the Teanaway River. In the Teanaway Formation, we have highly resistant forming prominent steep-sided ridges and are best exposed in the south edge, a bluff overlooking the town of Easton. That's the bluff we're featuring here today. The Teanaway Basalt consists of flows of dense, black, very fine-grained aphanitic basalt, pyroclastic rocks composed predominantly of highly altered, poorly sorted fragments of pumice and lava. Oh, that's interesting. I didn't know that. Both the flow rocks and the pyroclastics weather reddish brown, so like red top, if you know that, is this Teanaway basalt. Bedding is thinner and more clearly defined than in the Silver Pass. I agree. Silver Pass are now out a bit more beautifully prominently. Let me zoom in as far as I can to get you up there. I mean, has anybody been up there to look at the Silver Pass volcanics in the last 20 years? The answer is yes. Jeff Tepper and his students have been up there. Yes, Mike Eddy's been up there. We're about to go to their more modern work. But I like reading these old papers as well. There's breccia zones within the Teanaway Formation. Up to 70% breccia-sized fragments, 30 to 50% lapilli, 30 to 50% tuff-sized fragments. I find it interesting there's no talk of rhyolite here, and I thought the basal section of the Teanaway Formation was rhyolite. Okay, bring in the big guns. Bring in Mike Eddy with his fancy laboratory techniques to really narrow down some dates, please. Can we get some precise ages on the Silver Pass volcanics and maybe even the Teanaway, maybe even the Swak? We can do that. So here's Mike Eddy, 2017, telling us about the Silver Pass volcanics and sampling from the Silver Pass volcanics. And Mike got 2 ages from the Silver Pass volcanics. 51.515 plus or minus 0.028 million. And also from the Silver Pass volcanics, Mike Eddy, 51.364 million years ago, plus or minus 0.29 million. And Mike is always careful to point out that previous ages published on the Silver Pass had incredible age ranges, error bars huge, like 49 plus or minus 5 million years ago, 50 million years ago, plus or minus 1.2 million years ago. So Mike is changing the game with his precision. Mike also has a precious date from the base of the Teanaway Formation, and his date is 49.341 plus or minus 0.033 million years. And I think that's at the base of the Teanaway, and I think that's his rhyolite that Dave isn't talking about. So you've got it, 51 million years old for the Silver Pass volcanics, 49.3 million years for the base of the Teanaway Formation down here in the trees. What is the significance of these dates and the chemistry? That's how we finish here today. And I'm just gonna flip you around. All right, let's walk and talk. I didn't bring those papers, but our friend Jeff Tepper has been doing some work not only on these 2 units, but he's been publishing a lot of regional significance, plate tectonic significance of these units. The Teanaway Formation and the Silver Pass volcanics are now viewed by Jeff Tepper as part of his Breakoff Belt. 51 million years ago, up through 49 million years ago, there is a linear pattern cutting through the Cascades that have unique chemistries and specific map patterns with specific ages, where Tepper is confident that he has a break a break of an ocean plate underneath the surface of Washington 51 to 49 million years ago. And that Breakoff Belt, as it's known, is not magmas being generated by a subduction zone, but instead we're too early for that. We're too early for the Cascade volcanic arc, says Jeff Tepper. Jeff Tepper says, yeah, I know you're in the Central Cascades. Everybody would call this the Central Cascades, but those are not Cascade volcanic arc lavas. Instead, Tepper says, we were just about to start the Cascades, but we're immediately after the accretion of Silesia and the clogging of the trench by this massive large igneous province known as Silesia caused the subducting plate to break underground. And the Breakoff Belt is just like it sounds. That Farallon plate detaches from Silesia, and hot mantle is surging up through the break and triggering melts shallower than mantle should be. The hot mantle is generating magmas unrelated to a subducting plate. Or if you want to think of it the other way, this is a situation where we have lavas and pyroclastic flows and basalts and even rhyolites that are being created because of a hole in a plate as opposed to a subducting ocean plate. And you're like, where have I been? I've never heard this before. Well, it's emerging new narratives from this guy, Jeff Tepper, who's a friend of ours. He's been on many of the programs. This is Mr. Mafic Enclave himself. This is the guy that was out of Teanaway Rock. This is the guy that gave a talk on Friday live at Central Washington University, Jeff Tepper. He is doing very important work, and it's brand new work. And I'm doing my best to showcase his work to many of you who have an interest in what's going on. But there is, maybe I won't say this as dramatically as I want to right now, there is a major revolution happening right now in tectonic understanding of many of these units in the Cascades. It's not all subduction related. There's many of these units, including today's feature, Teanaway Formation and Silver Pass Volcanics, that are erupting before, a few million years before the birth of the Cascade volcanic arc, 46 million years ago. Okay, a little impromptu field video from Lake Cascades in the last couple of days of October 2024. Thank you so much for watching this short video. Hope you enjoyed it, and we'll see you next time. Goodbye from Central Washington.